Hello, pre-calc students. This is Mr. Beck. Today we're going to be solving trig equations, which is one of my favorite lessons this semester. Just a quick recap of where we've been. In 6.1, we started by looking at angles, and we found the measure of the arc from the angles. We found the area of the sector. Then in 6.2 and 6.3, we started talking about what are all the 6 trig functions of each of those angles, and then we developed a unit circle from that. 6.4 to 6.6, we started graphing all the different trig functions, and we looked at how they looked when we looked at all the angles, not just one of the angles. 7.1 and 7.2, we said, okay, we now have the ratios, and we said, what angle do they come from? And when we look at those angles, we said, okay, if they're functions, we have limited angles that they could come from. So now, when we're solving trig equations, we're going to be kind of working fluidly with all of those different ideas. So to start off with, I have this equation 2 cosine theta plus 1 equals 2. So I am going to solve this trig equation. And if you just a quick recap of how to solve any equations, if we could look through order of operations, PEMDAS, to solve any equation, we undo each one of these: undo addition, subtraction, undo multiplication, division, undo exponents and logarithms, then undo parentheses, and really all grouping symbols. Now, when it comes to trig, trig is going to fit into those grouping symbols because we will say the sign of something. We will say the cosine of something, which creates that grouping. So when we do the undoing, then we're going to be undoing sign, which allows for whatever is inside the trig function. So you'll see where this is going to come into play. So when I take a look at problem 1a, what I will look at is if I subtract 1 from each side, then I have 2 cosine theta equals 1. And then divide both sides by 2, I get cosine theta equals 1/2. Now, just as a quick idea, where on the unit circle does the cosine equal 1/2? That theta is at the x values of 1/2. So that theta is pi over 3 if we're looking at quadrant 1. And then what happens if we're looking at quadrant 4? That theta is going to be 5 pi over 3. Now, that's the basic approach that we're going to be taking in these problems. Officially, algebraically, we will take the inverse cosine of both sides. So the inverse cosine of the cosine equals the inverse cosine of 1/2. That's where we get theta equals pi over 3. Now, pi over 3 is the principal angle that comes out of the inverse cosine, but we are no longer limited. And that's the one big thing that I want to focus on is we are working within 0 to 2 pi. So the angle that comes out of the inverse cosine is the pi over 3, but keep in mind our problem is the cosine equals 1/2, not the inverse cosine of 1/2. So how the problem starts is always very important. Just like if I have x squared equals 9, then x would equal the positive or negative square root of 9, which is positive or negative 3. Versus if I just said x equals the square root of 3, there's only one solution here. There's one solution based off of the domain and how we start. Here, we have 2 different solutions that come out of the problem. So we are going to have multiple solutions, and we're going to be looking for those solutions which exist on the interval from 0 to 2 pi, which is what those do. Looking at problem number 1b. So with 1b, we're going to start by adding 1 to both sides, then dividing both sides by 4. Now, then we now have the square that we're going to be working with. So in terms of order of operations, we undo the square by taking the square root of both sides. So the square root of sine squared of theta equals positive or negative square root of 1/4. And then the sine of theta will equal positive or negative 1/2. So what's going to happen here is we have 2 solutions. The first solution is going to come where the sine equals positive 1/2. So it's where the y value is 1/2, which gives us these 2 solutions. So what I'm looking at is where does the sine of theta equal 1/2? The theta is going to equal the angles in quadrants 1 and 2, which give us the y value of 1/2. That would be pi over 6 and 5 pi over 6. Then we have the second equation, which I will do in a lighter blue, is where the sine of theta equals the negative 1/2. And so that would be in quadrants 3 and quadrants 4, where the y values are negative 1/2. And that theta is going to be 7 pi over 6 and 11 pi over 6. So as I said, we have two different equations that we're working off of. Those equations are going to be the sign is the positive square root and the sign is the negative square root. Moving right along. Let's look at C. The square root of 3 cotangent theta minus 3 equals 0. So first step is add 3 to both sides. So square root of 3 cotangent of theta is 3. Second is divide by the square root of 3. So cotangent of theta is 3 over the square root of 3, which is just the square root of 3. Where does the cotangent equal the square root of 3? We're looking at the two quadrants where, in essence, the tangent of theta is going to be the reciprocal, which is the square root of 3 over 3. You can interchange between these two. The one thing we have to just watch out for is potential domain errors. But anyway, it's where the slope is the square root of 3 over 3. That would be at theta is pi over 6. That would be our quadrant 1 answer. And then we have our quadrant 3 answer of 7 pi over 6. I'm going to pause here for just 1 second. All right, picking back up. I will look at D. So when it comes to a problem like this, the way that I look at this is almost as if we have a substitution. What happens if y equals the sine of theta? So the problem that we're looking at is kind of like 2y squared minus y equals 0. So when I encounter a situation like this, this substitution is very helpful because it helps me take it back to something that I'm used to doing already. If you remember, we do factor problems by factoring out a y from both terms. We get y times 2y minus 1 equals 0. So by factoring, we now have y is going to equal 0 from here. We are going to have 2y minus 1 equals 0 from here, which gives us y equals 1/2. Now, keeping in mind that y was the sine of theta, we can then say, okay, where does the sine of theta equal 0? And where does the sine of theta equal 1/2? So the sine of theta equals 0, where our y values are 0. So that would be at theta equals 0 and at pi. And then the second situation is where the sine of theta equals 1/2. We've already done one of those. That's where the y values are 1/2, which will be at theta equals pi over 6 and theta equals 5 pi over 6, because we want that quadrant 2 answer as well. So one of the big questions that comes out of the problems that we have here is how many solutions am I really expecting? Because as I began and I said, hey, we're going to be working over this interval from 0 to 2 pi, we will have 2 solutions that come out of just about every single one of the trig functions that we're going to be working with. So we have cosine of theta here on problem number 1. We ended up with 2 different solutions that came out of that. That's the pi over 3 and the 5 pi over 3. Now, when I looked at part B, I have the sine of theta, but it's not just the sine of theta, it's the sine squared. So each sine is going to give me 2 different potential solutions. So I was expecting 4 solutions out of that problem. On part C, it was just cotangent, and cotangent ends up having solutions twice. That was the pi over 6 and the 7 pi over 6. Where part D, I had a sine squared, and this is kind of like quadratic in nature that we saw here, that since we have a quadratic had 2 solutions. Not that one, it would be the y equals 1/2. But since each part of the quadratic was trigonometric, each one of those had 2 solutions that came out of that, for a grand total of 4 solutions. So as I look at all the problems, I'm going to start to say, how many different solutions am I really going to expect from each one of these problems? And I have some noise in the background, so I need to pause. All right, I think the noise is past. Hopefully it's past. Moving right along. So when I look at question number E, or question 1E, how many solutions do I expect out of this? Well, I'm seeing that it's going to be trigonometric. With the trigonometric, there's 2 solutions that come out of each trig. And because it's squared, I'm going to have 2 more solutions. So I'm thinking I'm going to have 2 times 2 solutions, which is 4. Now, with this, let's go ahead and do a substitution again. Because cosine tends to follow the x value, I'm going to, let's say, x equals cosine of theta. So my problem is really 2x squared minus 5x plus 3 equals 0. And so we will factor this. We know that this must be 2x times x. And what multiplies to give us a positive 6, but adds to give us a negative 5. That would be a negative 2x and a, not positive, and a negative 3x. So 2x minus 3 times x minus 1 equals 0. That means x is going to equal 3 halves, and x is going to equal 1. I kind of jumped over that. 2x minus 3 equals 0, and x minus 1 equals 0, which is why I get x equals 3 halves and x equals 1. But x actually represents cosine of theta. So where does cosine of theta equal 3 halves, and where does cosine of theta equal 1? So where does cosine equal 3 halves? What that says is where on the unit circle, which has a radius of 1, does the x value equal 3 halves? That would be nowhere. So there are false solutions that could potentially come out of this. And then where does cosine of theta equal 1? Well, cosine of theta equals 1 only occurs here at the point 1 comma 0. So theta actually equals 0. Now it's going to equal 0, and while I agree that 2 pi is a potential solution, if we go back to the original domain that we had here, which I'm circling, theta is not allowed to equal 2 pi. It's only allowed to equal 0. So we tend to look from 0 to 2 pi, including the 0 but not the 2 pi. That's pretty standard. So while 2 pi would potentially work, that's not on the interval. It's not in our domain. It's not in the actual domain. So our answer is only theta equals 0. So when it came down to this problem, I was expecting 4 solutions. I was expecting 2 from the cosine and then 2 more because of the squared, but I really only had 1 solution. And that's okay, because for me, it's about how do I recognize how many solutions can potentially occur, and can I account for all of those? You're only going to get 1 solution whenever you have cosine equals 1 or cosine equals negative 1. You'll have 1 solution when sine equals negative 1 or sine equals 1. For pretty much all of the other ones, I guess secant equals 1, cosecant equals 1, and negative 1, of course. There are only going to be single solutions for those as well. But accounting for all the solutions is the important thing. I only have 1 that comes from here, and here are 2 false solutions. One of the things that I like to do is I like to take a look at the graph of this as well. So if I look, and I'm going to go ahead and type in 2 cosine of theta. So 2 cosine, we have to put it in as x here. So 2 cosine squared, and then minus 5 cosine theta. So 5 cosine x plus 3. I want to look at where this crosses the x-axis because that's where it equals 0. What you can see is that's only occurring right here at x equals 0. It could occur here, which is at the 2 pi, and then this one would be the negative 2 pi, but it's only going to hit the x-axis once. All right, moving right along. So now, if I take a look and do a substitution, I have y for sine and I have x for cosine. So this problem says 1 plus y equals 2x squared. So it comes down to this problem really can't be done because I have a mixture of 2 separate trig functions, which leads to that question, is there a way that we can turn sines into cosines or cosines into sines? And the way that we know goes back to the most important Pythagorean triple, sine squared theta plus cosine squared theta equals 1. So, excuse me, if sine squared plus cosine squared equals 1, we have 2 potential outcomes. We could say sine squared is equivalent to 1 minus cosine squared theta, or we can say cosine squared theta equals 1 minus sine squared theta. Now, how do I know which approach to take? Our goal is to turn sines into cosines or cosines into sines, and we only have 1 squared. The squared that we have is our cosine squared, so we're going to have to use the second case that cosine squared equals 1 minus sine squared. So, going back to our problem, 1 plus sine of theta is going to equal 2 times 1 minus sine squared theta when we do that substitution. That substitution is cosine squared is 1 minus sine squared. Let's do a little bit of algebra. 1 plus sine of theta equals 2 minus 2 sine squared theta. This is another quadratic trig function. as a quadratic trig function, we want to get everything to one side of the equation. So let's take everything to the right side, where we have 2 sine squared theta plus sine of theta, and then minus 1 is going to equal 0. So at this point, do you need to do the actual substitution? Should I put that y equals sine or or x equals cosine? That's going to be completely up to you. I'm going to prefer to not actually write that just because it's not needed. But if you need to, just remember y equals sine of theta so that we have a quadratic mentality. So let me actually do this one more time. So 2y squared plus y minus 1 equals 0. I know that when we factor this, this is going to be 2y and this is going to be y. I know both of these have to be 1 because those factors are 1 right here. Question is, where does the positive and where does the negative go? The negative will go here, the positive will go here, and that's because 2y times y is y, and then negative 1 times y is negative y, and those add up to be just a positive 1y. So this is where 2y minus 1 equals 0, so y will equal a half, or that's where sine of theta equals a half. Because I'm running out of space, I'm going to go ahead and put sine of theta equals 1/2. And here is where y plus 1 is going to equal 0. So y plus 1 equals 0. So sine of theta is going to equal negative 1. So how many solutions am I expecting out of this? I am expecting 4 solutions out of this. The first 2 come from where sine of theta equals 1/2. That's where the y value is 1/2. Theta is going to be pi over 6 from quadrant 1 and 5 pi over 6 from quadrant 2. And then where does sine equal negative 1? That'd be down here. That's where theta equals 3 pi over 2. I was expecting 4 solutions, but I really only have 3 solutions. And I'm okay with that because this is only going to yield 1 solution. All right, moving right along. We have our next one. So secant theta plus, or secant squared theta plus tangent theta minus 1 equals 0. So this time I don't have sines and cosines, I have secants and tangents. So if you remember, we have our Pythagorean triple, sine squared theta plus cosine squared theta equals 1. And since we have secant squared, I have to figure out how to turn this Pythagorean triple into the secant squared, and that secant squared comes from 1 over cosine squared. So tangent squared theta plus 1 will equal secant squared theta. What that means is we can substitute tangent squared theta plus 1 in for secant squared theta. So I have tangent squared theta plus 1 plus tangent theta minus 1 equals 0. And do a little bit of algebra. Tangent squared theta plus tangent of theta is going to equal 0. Now, if you need to do a substitution, a lot of times I like to put m equals tangent theta if you really want to, but this one probably doesn't need it. If we factor out a tangent of theta, we have tangent of theta times tangent of theta plus 1 equals 0. So we have, where does tangent of theta equal 0? Or where does tangent of theta plus 1 equal 0? So where are my slopes 0 on the unit circle? That would be over here. So slope equals 0 here. That's theta equals 0. Slope also equals 0 over here. That'd be theta equals pi. Now, where does my slope equal? I haven't actually solved. Where does tangent of theta equal negative 1? My slope equals negative 1 in quadrant 2. That would be at theta is 3 pi over 4. And then in quadrant 4, that's theta equals 7 pi over 4. So how many solutions did I get? 4, and I was expecting 4 because each trig should yield 2 solutions, and because this is a quadratic trig, that would be 4 solutions. And then H, cotangent of theta equals cosine of theta. So in a situation like this is actually beginning our approach to say, how do we work and manipulate with the different trig functions, be able to simplify, solve lots of different things. So cotangent of theta and cosine of theta, there is not really much of a link between cotangent of theta and cosine of theta. So we're going to have to use one of our trig identities, and that's where cotangent of theta is going to equal cosine of theta over sine of theta. So if I look at it that way, cosine of theta over sine of theta equals cosine of theta. So now I have a link between the two that says, or that link is cosine of theta. Now, be careful. I'm going to write this big warning. Warning. Do not divide by cosine of theta. That's the biggest mistake people make, because if you divide by cosine of theta, you actually will lose zeros. So do not divide by any of the trig functions unless you know you're not going to lose any zeros. So how do we work through this instead? Cosine of theta over sine of theta minus cosine of theta is going to equal 0. We can factor that cosine of theta out, and we're left with 1 over sine of theta minus 1 equals 0. So 1 over sine of theta, hopefully you all know, is going to be equivalent to cosecant of theta. So I now have the factors cosine of theta and cosecant of theta minus 1 equals 0. So where does cosine of theta equal 0? That's where my x values are 0. So that would be that theta equals pi over 2 and 3 pi over 2. And then where does cosecant of theta equal 1? So cosecant of theta minus 1 equals 0. So cosecant of theta equals 1. That would be where the reciprocal of the y value is 1, or pi over 2. So if you notice, we have a repeated solution that came out of this. So your thetas are only going to equal pi over 2 and 3 pi over 2. Now, how many trig solutions was I expecting? I was expecting just 2 solutions, potentially 4 solutions, because those aren't the same. We only ended up with 2 because we did get 2 out of here. This only yielded 1, but it happened to be a repeated one. So again, for me, accounting for where are all my 4 solutions, even though I don't get 4 solutions, accounting for that is important to me, because then I have comfort that I know that I have answered all of these appropriately. All right, so now I'm solving on the interval from 0 to 2 pi. So in order to solve on the interval, excuse me, from 0 to 2 pi, again, as we undo addition, subtraction, undo multiplication, division, undo my exponent parentheses, which we won't have all of those, and then undo exponent, or undo grouping, excuse me. So I jumped over that. That was exponents, logarithms, and then grouping in parentheses. The first step to this problem is let's add 1 to both sides. So tangent of 3 theta equals 1. What I want to do is I want to go to the graph of this one, because I think the graph helps us understand it a little bit better. So let's scroll up here. Let's clear these out. First thing that I want to do is analyze what's the difference between tangent of x and tangent of 3x. So if tangent of x looks like that, and tangent of 3x, what will it look like? If you remember, this is a horizontal compression. As a horizontal compression, we have so many more of these graphs because the period just got shortened. Usually the period, if you remember our graphing, our period used to be pi, but now it's pi divided by the b value, so it's just pi over 3. So as pi over 3, you can see that this tangent graph is repeated so many more times. For that reason, let's go back up here. I'm going to delete out this graph, and I'm also going to change the settings just so it doesn't look quite so it doesn't look quite so busy. So I think I'm actually in the wrong menu here. So document, settings. No, I take that back. I want menu and window. So let's do, nope, I think it's zoom trig. I don't get to do enough of these, which is what's sad. So window, I can get there eventually. So zoom trig, that's a little bit better. Now I'm going from 0 to 2 pi, and you can see our period is still pi over 3. Now what I want out of this is, wrong button. What I want out of this is, where does tangent of 3 theta big sign. Where does tangent of 3 theta equal 1? So what I'm looking for is this solution right here. We're looking for this solution right here. The solution right here. Uh-oh. I have a total of 6 solutions from 0 to 2 pi. 6 solutions where tangent of 3 theta equals 1. So I was expecting how many solutions? I was personally expecting maybe 2 solutions out of this. But because of the 3 theta, because that got changed, I have to think about, okay, that compression by a factor of 3 means I'm going to have 3 times the number of solutions. So I'm actually should be expecting 6 solutions out of this because 2 solutions normally times the compression of 3 is going to give me 6 separate solutions. Okay, with that in mind, let's go ahead and find all of our solutions. The way that we do this is I now say 3 theta, or at least one approach. This isn't the only approach, but one of the approaches I like. I need to work on the interval 3 theta. This interval theta goes from 0 to 2 pi. So if I multiply that interval by 3, what this means is I am now solving for all the solutions for 3 theta on the interval from 0 to 6 pi. So that's where I get 3 times the number of solutions. With that said, tangent of 3 theta equals 1. The first thing I'm going to do is do the inverse tangent, just as that mentality. Inverse tangent of the tangent of 3 theta equals the inverse tangent of 1. That's where undoing the grouping comes into play. That 3 theta is going to equal, well, where does tangent equal 1? So on the unit circle, that's where my slopes are 1. And I'm going to expand this just a little bit so that we can see it a little bit better. So first, tangent of 3 theta equals 1 at pi over 4. And then in quadrant 3 at 5 pi over 4. So that's going around the unit circle once. But because it's 3 theta, what's happening is we have to go around again. So if you think about it, so 5 pi over 4, 7 pi over 4, 9 pi over 4 will be this solution. And that would be our quadrant 5, if you will, as we keep going around the unit circle. So that would be 13 pi over 4. And we have to go around one more time. The reason why we have to go around one more time is because it's 3 theta, not just theta. So I'm trying to choose a color here. So as I continue going around on my 3rd attempt, so it's kind of like 3 cycles through, that's 17 pi over 4. And that's hard to read for you guys. So let me darken that color just a little bit. 17 pi over 4. That would be this one. And then that's 19, so that's 21 pi over 4. So I have a total of those 6 solutions. One of the approaches that I like to take, I mean, I tried to show it visually, which I'm not sure how well you guys are understanding that visual. Some students benefit really well, some students don't. One of the approaches that I do like to take here is pi over 4 and 5 pi over 4 are the ones that we know really, really well because those are from 0 to 2 pi. Now, how do I get the other ones? From here, if I go coterminal and I add 2 pi, from here, if I go coterminal and I add 2 pi, and when I say add 2 pi, because it's over 4, 2 pi is equivalent to 8 pi over 4. So if I add 8 pi over 4, that's how I'm going to get the additional ones. So that's how I'm going to get coterminal with the quadrant 1 and quadrant 3 answer. But because it's 3 theta, I still have to go again. And I have to say, okay, let's add 2 pi here, or add 8 pi over 4 here. And from here, add 8 pi over 4. And that's how I'm going to get all of those solutions. Now, if you think about solving equations, I now have what's inside the expression, which is the 3 theta. So if I divide everything by 3, it's going to be pi over 12, 5 pi over 12, 9 pi over 12, which can reduce to 3 pi over 4. Then I have 17, I jumped 13 pi over 12, 17 pi over 12, and 21 pi over 12. which that one could also reduce to 7 pi over 4. So those are my 6 solutions. And I'm not going to highlight that one. I'll highlight that one. So those 6 solutions, again, just as a recap, what did I do? First, I need to see what all of my solutions were, or at least what interval. That was 0 to 6 pi. And I did that by multiplying the interval by 3. And the reason by 3 is because it's 3 theta. Now, when I solve, I get the 2 solutions that I know. To get all the other ones, I have to add 2 pi to each one of those solutions, add 2 pi to each one of those solutions. That made that one a little harder to read. So with that in mind, then I divided by 3 because it was 3 theta, not just theta. Now, all of these solutions, if you notice, are on the interval from 0 to 2 pi, which is what we wanted in the end. So what I did here is kind of like a cheating approach, just to say I need all of the angles that are between 0 and 6 pi, because at the end, by dividing by 3, it now gets me all the angles between 0 and pi, or 2 pi. So let's actually look at C first, just because it's going to be a little bit more similar, and then we'll get all crazy with B. So on C, my first step is to subtract 2. So 4 cosine 2 theta equals -2. So cosine of 2 theta is -1/2. Now, 2 theta is going to be where cosine equals -1/2. Cosine equals -1/2. We haven't done any of these today just yet. So cosine equals -1/2 at 2 pi over 3, 2 pi over 3, and at 4 pi over 3, which is right here. So that's on the interval from 0 to 2 pi. Now, what interval do I want? So 0 is less than or equal to theta, less than 2 pi. Because it's 2 theta, it'll be 0 less than or equal to 2 theta, because I'm doubling everything, 4 pi. What this means is I have to do 2 full rotations. So the first rotation was the 2 pi over 3 and 4 pi over 3. If I add 2 pi to each one of these, and in this case 2 pi is 6 pi over 3, that would be 8 pi over 3. And if I add 2 pi here, that would be 10 pi over 3. So 2 theta is going to equal each one of those. So now when I'm dividing by 2, by dividing by 2, I now have theta is 1 pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So I have these 4 solutions that I need to, or that I have as my solution. And I need to pause my recording. And I'm resuming. So benefit of having all of my children at home with me today. I love my children. My 4 solutions, and those solutions are on the interval from 0 to 2 pi. So again, kind of the cheating is to say I need to take 2 full rotations, but by dividing by 2, it takes me only on the interval from 0 to 2 pi. So let's look at B. What happens with B? First thing we need to do is undo the +2. So 3 secant of theta over 2 plus pi over 3 equals -3. We divide both sides by 3. So secant of theta over 2 plus pi over 3 equals -1. Now, what angles am I looking at that are going to be coming out of this problem? So if I go 0 is less than or equal to theta is less than 2 pi. First thing I want to do is divide everything by 2. So theta is equal to theta over 2, less than or equal to theta over 2, less than pi. And now if I add pi over 3 to everything, pi over 3 is less than or equal to theta over 2 plus pi over 3, which is less than pi plus pi over 3, which would be 4 pi over 3. So what I was trying to do, my goal, was to make what's inside here out of the original domain from 0 to 2 pi. So the only angles that I am going to be able to use are the angles between theta or pi over 3 and 4 pi over 3. So where does secant of theta equal -1? So secant of theta equals -1 whenever cosine of theta equals -1. So this is where cosine of theta equals -1. So if I take the inverse secant of both sides, theta over 2 plus pi over 3 can equal where cosine of theta equals -1. That would be at pi. Now pi is on the interval from pi over 3 to 4 pi over 3, so this should be a viable solution. Now, if I really wanted to just kind of pretend and say secant is -1 at -pi, let me change colors. Let's make this red, as in danger. This is not going to work. So -1 is, or -pi is not on the interval. But if it were, let's see what would happen. So now if I subtract pi/3 from each one of these, I now have θ/2 equals 2pi/3. And -pi minus pi/3 is -4pi/3. Now, as I'm solving, I'm going to multiply everything by 2. So θ equals 4pi/3 and -8pi/3. So as we noticed, we said, hey, this is not going to work. So what doesn't work is this -8pi/3 is not on the interval 0 to 2pi. Excuse me. But the 4pi/3 is on that interval. That 4pi/3 is on that interval, which is what we expected. So I guess what I was trying to model here was, let's assume what happens if we have an answer that's not going to be on the interval. I could have done that with any of the other two problems if I wanted to. But if the answer is not on the interval, by kind of manipulating that interval to say what angles are we looking for, this one was not, and the resulting angle was not on that interval as well. All right, next problem. Where does cotangent squared of 2θ/3 equal 1? So the first thing is we still have a squared that we have to worry about. So take the square root of both sides. But biggest danger, people always forget that positive or negative. So I like to show it as where does cotangent of 2θ/3 equal 1? And where does cotangent of 2θ/3 equal -1? So what intervals am I looking at? We should be going 0 is equal to less than or equal to θ, less than equal to 2pi. So if I multiply everything by 2/3, the only viable answers that I'm going to work on, that's just 20. The only viable answers that I'm going to be able to use are from 0 to θ/3 to 4pi/3. So any answer that I get that's outside of that interval from 0 to 4pi/3 should not work in the end. But let's take a look at this. Cotangent of 2θ/3 equals 1. So that would be wherever the reciprocal slope equals 1. So 2θ/3 is going to equal pi/4 and 5pi/4. Now, where does the slope equal -1? Let's change colors on this one. So where does the reciprocal slope equal -1? So 2θ/3 equals 3pi/4 and 7pi/4. Now, I'm hoping some of you recognize 7pi/4 is larger than that 4pi/3 angle. I'm hoping you guys caught that. If you guys caught that, great. So what that means is this is a solution. This is not going to work. And I want to identify that this is not going to work right away. The other three should, but that one will not. And a lot of people are like, why doesn't it work? Okay, it's outside of my manipulated domain, but at the same time, you'll see. So let's solve the first two. If I multiply both sides of the equation now by 3/2, I will get θ equals 3pi/8 and 15pi/8. We're over here, if I multiply both sides by 3/2, I will get θ equals 9pi/8 and 21pi/8. So why doesn't this work? 21pi/8 is bigger. So this is bigger than 16pi/8. 16pi/8 is 2pi, which is why that is outside the domain from 0 to 2pi. So my only solutions are going to be those three. All right, lots of things to worry about on this problem. Number one, don't forget the positive or negative square root of 1. So positive square root of 1, negative square root of 1. Number two, as you look at the solutions, I manipulated the domain to figure out what angles from 0 to 2pi I normally want to get. That way, when I solve, I do get those viable solutions from 0 to 2 pi. Now, some students, they don't like to do this kind of manipulation. They'll say, okay, I'm just going to come up with all the solutions that I'm familiar with and then figure out which ones are outside the domain. That is completely okay with me. All right, so in the series of problems that we've done, we've looked at a lot of different types of solving equations. We had some basic ones, which only had 2 solutions. We had some quadratics, and those quadratics then had 4 solutions. Then we said, what happens if we have a mixture of sines and cosines or secants and tangents? Then we have to convert the sine squared into cosine squared or cosine squared into sine squared. Had a type of problem where cotangent equals cosine, so we had to get everything in terms of cosine so we could factor it out. So that was a technique that can be important. Then we said, what happens if we change the frequency so that it's not just theta, it's 3 theta. And we've had a couple different ways we could work through those. Now, we're going to go ahead and switch up and say, we are now solving the equations over the set of real numbers. We are not as concerned with 0 to 2 pi, but we want every possible solution. So as I look at the graph over here, every possible solution, can I come up with a formula that's going to give me the solution for everything, which is a little bit harder to do. So we tend to make the equations maybe just a little bit easier, just because we're going to have lots and lots and lots of possible solutions. So first things first, I am going to solve this and say, where does sine of theta equal 1/2? Now, where does sine of theta equal 1/2? As I'm visually graphing it, sine of theta equals 1/2. We've done this a couple times where theta is going to equal pi over 6. So pi over 6 is going to be the principal angle that comes out of this. The other angle that comes out of it is, or the other principal angle, is going to be theta equals 5 pi over 6. And I didn't mean to write it there. I meant to write it here. So those are the 2 angles that we tend to focus on from 0 to 2 pi. But let's look at that pi over 6. It's not just pi over 6. If I go 2 pi again, I now have, what is that, 13 pi over 6? And if I continue to go around again, then I'm going to have add another 2 pi, and then add another 2 pi, and then another 2 pi. So what ends up happening is everything coterminal there ends up being a possible solution. Well, how do I show coterminality? This is kind of like how we did domain where we had asymptotes. So every 2 pi afterward is what that represents. So we'll say pi over 6 plus 2 pi n, because we're going to say every pi over 6 and then every period thereafter. So 5 pi over 6 plus every period thereafter. So this is every period after, which is where coterminal comes into play. All right, so I know that's kind of a weird way of looking at it, but this is now beneficial because this allows us to find every possible solution. If n is 5, then pi over 6 plus 10 pi is going to be a possible solution to this equation. For part B, cosine squared plus cosine theta equals 0. To first solve this, we're going to have to factor out a cosine. So cosine of theta times cosine of theta plus 1 equals 0. So I want to know, where does cosine of theta equal 0, and where does cosine of theta plus 1 equal 0? Cosine of theta will equal 0 at theta equals 0. No, I'm just kidding. That would be pi over 2, because cosine is where the x value equals 0. So that would be pi over 2 and 3 pi over 2. So theta equals pi over 2 and theta equals 3 pi over 2. Now we can go ahead and do that coterminal mentality, because if we add 2 pi onto here, and then add another 2 pi, then add another 2 pi, we will get all the possible solutions up there. So plus 2 pi n, 3 pi over 2 plus 2 pi n, because every period thereafter. And then where does cosine of theta equal -1? That'd be at theta equals pi, and then every 2 pi thereafter, because every period after. maybe some of you have recognized that these two expressions could actually be simplified to say, okay, we have pi over 2, but if we go pi, we end up at the 3 pi over 2. If we go pi, we end up at 5 pi over 2. And just by adding pi, we can meet all those solutions. I really don't like that button there. We can turn both of those expressions into a simpler expression by saying theta equals pi plus pi n. So I will accept all of these as potential solutions along with this, but these two expressions tend to be a stronger form because this one equation will take the place of both of these two equations. All right, moving right along. First thing first, tangent of theta equals the negative square root of 3. So where does my slope equal the negative square root of 3? That would be in those two quadrants. So first, it's negative square root of 3. We say 2 theta is going to equal 2 pi over 3. And 2 theta equals 5 pi over 3. Now, one of the things about tangent is its period is pi, so it tends to be very geometric already. So rather than doing this, we can just, I guess I haven't finished this, and then every period thereafter, and then every period thereafter. So if you notice, this expression actually is the same thing as this expression, because if n equals 1, this will now be 2 pi over 3 plus pi, which is already 5 pi over 3. So with tangent tends to be geometric. We don't have to write all the solutions because it's already built into this part of the expression. So for that reason, I'm going to scratch this out and say we're not going to use it. We'll go back to 2 theta equals 2 pi over 3 plus pi n. Now this is going to be the first situation where I have a 2 theta. So I have to divide by 2. And if I divide everything by 2, then theta is going to equal pi over 3 plus every pi over 2n afterwards. So this concept tends to be a little hard for students. So if you're not seeing it right away, don't feel bad, especially when it comes down to you have to look at the circles geometrically to figure out what's going on. Why are you just adding pi? Why are you adding 2 pi? For tangent, the period is pi, which is why I could say every period thereafter. Sine and cosine, the period is 2 pi. And secant and cosecant, the period is also 2 pi. So a lot of times we'll use plus 2 pi n for each one of those. For D, cotangent, I'm just going to warn you right now, cotangent's period is pi. So this one's going to be geometric, just like this, like C was. So first step, cotangent squared of theta over 2 equals 3 because I'm adding 2 to both sides. Cotangent of theta over 2 equals positive or negative square root of 3. Please, 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 please don't forget when you take the square roots, you have to take both the positive case and the negative case. So cotangent of theta over 2 equals the square root of 3. Cotangent of theta over 2 equals the negative square root of 3. So where does cotangent equal the square root of 3? It's where the reciprocal slope is the square root of 3, which would be here. Theta over 2 is going to equal pi over 6, and then every period thereafter. And every period thereafter is going to cover that one, that one, that one, et cetera, et cetera. So now, in order to solve for theta, though, I have to multiply by 2. So theta is going to equal 2 pi over 6, which is pi over 3, plus every 2 pi n afterwards. But wait, there's more. Where does reciprocal slope equal the negative square root of 3? That's going to happen at theta over 2 equals 5 pi over 6, plus every period thereafter. So here's your 5 pi over 6. There's one period after, there's one period after, et cetera, et cetera. And then when I multiply by 2, I will get theta equals 5 pi over 3 plus every 2 pi thereafter. So these two expressions are going to yield every single possible solution that will exist for this equation. Something I do like to do is check to see if there's a geometric way that I can simplify those two, and everybody, the answer is there is not. So the last series of problems I'm going to do are problem number 4. I'm not going to do number 5 just because this video is already long enough, and I just want to focus on making sure you understand the essential skills. So for 4A, and I'll look at this, I'm going to zoom in really closely because sadly I didn't leave enough room on the notes, and my apologies. So now we're going to be using the calculator to solve all of the following equations. We're back on the interval from 0 to 2 pi. I'm sorry I keep jumping domains, but everybody, that's why domain has been so important all year, because we need to say what solutions are going to exist for maybe this limited solution or this limited situation, or maybe a more complicated one. So for 4a, where does cosine of theta equal 0.3? So the way that I look at this is, where does cosine equal, or where does my x value equal 0.3? So my x value is going to equal 0.3 in both of these two situations. That would be quadrant 1 and a quadrant 4 answer. Okay, I don't know this ratio of 0.3, so let me go and say, the very first thing that's going to happen is, what is the inverse cosine of 0.3? This is how I've been solving the equations. I haven't been showing all of that just because we've known a lot of the answers. We don't know this answer. Now, this is where 7.1 and 7.2 kick in. The answer that comes out of the calculator, which is what we're going to have to use, calculator answer for cosine, just as a quick refresher, cosine is in quadrants 1 and 2. So the calculator answer that's going to come out of here, it's a positive ratio. So that's a positive ratio. So that would be the quadrant 1 answer. So when I type in the inverse cosine of 0.3, this 1.2661, so theta equals 1.2661, this is the quadrant 1 answer. My job is to be able to also get the quadrant 4 answer. So let's change color to help see this maybe a little bit better. So this answer is theta is 1.2661. How do I get the quadrant 5 answer? There's not that symmetry by pi. If I add pi, I'm not going to be able to get the possible answer. But if I think about it this way, this angle down here should also be 1.2661. So the way that I'm going to get that is, I'm going to start off at 2 pi and subtract the 1.2661 to get the other solution. So 2 pi minus, and let's hit that, 2 pi minus that is 5.01, 5.017, and I'll just leave it at 3 decimals, which is what I tend to ask for anyway. So that 5.017 is our official angle right here. The way that I got it is 2 pi minus the quadrant 1 answer. So that leads me to kind of take a look to say, okay, we've talked about this a little bit before, where this angle here is theta. If we have symmetry over the y-axis, that's going to be pi minus theta. If we have the symmetry across the origin, that's pi plus theta. And our quadrant 4 is going to be 2 pi minus theta. So based off of the information that we're given, or that we get, we need to know what that theta from quadrant 1, and that's kind of important to know. If our theta is in quadrant 1, then how do we come up with any of the other 2 possible angles? All right, so let's check B. And I'm going to change my color back. So for B, sine of theta equals negative 0.7. So this is where the y value on the unit circle is negative 0.7. So negative 0.7, negative 0.7. I don't know that off the top of my head. Now, keep in mind, as I'm doing the calculator, if I do the inverse sine of negative 0.7, what should come out of this, because its sine is a quadrant -1 answer. So sine is negative in quadrant -1. Somehow I have to turn that -1 quadrant into an answer that's in quadrants 3 and 4. So let's go ahead first, type it in the calculator. what is the inverse sine of negative 0.7? That turned into times instead of minus. So let's try that again. Change the times to a minus. So that's negative 0.775. I really want to try that one more time just to be sure, just because negative 0.7. Okay, it is. So the answer that came out of the calculator is negative 0.775. And if you remember, I said that's a quadrant negative 1 answer. So how do I get that quadrant negative 1 answer into a quadrant 3 and 4 answer? So this negative, and let me kind of blow that up just a little bit, negative 0.775, if we look at the angle that would have occurred in quadrant 1, that's a positive 0.775. And as I kind of mentioned over here, it's important that that theta that we care about, that we're going to be working with, is that quadrant 1 answer, or is that quadrant 1. Then 0.775 is what sometimes referred to as a reference angle. So I want my quadrant 3 and my quadrant 4 answer, which would be pi plus the 0.775 and 2 pi minus the 0.775. So in the calculator, I'm going to say, honestly, I'm going to do it this way. I'm going to add 2 pi onto that, and this gives me the quadrant 4 answer. So theta is 5.507. I guess that would be an 8 if I do my rounding. And then the other one is going to be pi plus the 0.775. And I'm going to have to manipulate something here. Because it needs to be a positive, I'm going to make it into pi plus that positive angle. And that's my quadrant 3 answer of 3.917. So one of the ways that we can look at this, and I actually kind of prefer it this way, is the answer that came out of the calculator is the negative 0.775. If I go coterminal with that, that's where I'm going to get my quadrant 4 answer. And to get my quadrant 3 answer, I need to look at that as the reference angle of pi plus the 0.775, being quadrant number 3. Secant of theta equals 3. If you remember, we did this in 7.2. This is where the cosine ratio is going to be the reciprocal. So where does cosine equal 1/3? So as I'm looking at this, cosine is 1/3 in quadrant 1 and quadrant 4 again. So cosine is where the x value is 1/3. So inverse cosine of 1/3. Inverse cosine of 1/3. And of course, it's going to be 1.231. So theta is 1.231. This video has gone really long. And then how do I come up with the quadrant 4 answer? That would be 2 pi minus 1.231. So if I take 2 pi and I subtract my solution right here, 5.052. 5.052. So that's my quadrant 1 answer. This is my quadrant 4 answer. Where does cotangent of theta equal -2? Last problem that we're going to do. So this is where tangent of theta is -1/2. Now, where does tangent of theta equal -1/2 or cotangent equals -2? It's where my slope is -1/2. There's my beautiful daughter crying. So let's finish this video quickly. So where does my slope equal -1/2? Let's go ahead and do inverse tangent of -0.5. So this answer that came out of the calculator, the -0.464, this is a quadrant -1 answer. To get this as a quadrant 2 answer, let me add pi to that. So I'm going to take my answer and add pi. There's my quadrant 2. So theta is 2.678. And now let's go ahead and just add another pi so we can get our quadrant 4 answer. So add pi, and there we get our quadrant 4 answer, 5.81. Actually, that would be 20 if we do our rounding. That's our quadrant 2, that's our quadrant 4. So all of that work that we've done geometrically on the circle is very, very important. And I'm going to go attend to my daughter who really wants to be right now. Take care, everybody.